Today's talk is how to reduce scikit-learn training time. So quickly about me, for anyone who doesn't know me, I currently work in developer relations at Intel. I write a lot about AutoML and distributed computing. And I previously worked at Scripps Research back in San Diego, where I did a lot of research on like wearables like Fitbits. So as far as why you want to speed up scikit-learn, this is very common for machine learning in general, is that machine learning training time can take a long time. And if you're wasting a lot of time training, you're not actually doing a lot of machine learning work that could be more productive. So there's a lot of different ways to speed up scikit-learn, and quite a few. One of them is to upgrade your scikit-learn, which we'll talk about. One of them is changing your solver. We'll talk about what that means in 7 minutes. I'll also talk about distributed hyperparameter optimization techniques, as well as simply parallelizing or distribute your training. Because a lot of things in scikit-learn and Python in general are optimized for a single core, but you can do things on multi-core or even in distributed setting. So the easiest thing to do is to upgrade your scikit-learn. I know it's a really simple thing to say for a talk, but oftentimes releases have efficiency improvements for algorithms. So sometimes not just about the hardware you have, it's about making sure you use the hardware more effectively. Also, one thing to mention is that even with versions of Python, like 3.10 versus 3.11, there's efficiency improvements just with the Python language itself, and that can really improve your workflow. So just something food for thought. So one thing to mention here is algorithmic improvements. One of them is in the algorithms themselves. And over time, scikit-learn, as well as other libraries, have increased support for categorical features. If you're not a machine learning person, just think of it this way. If you have a column of animals, and you can have dog, cat, cheetah, whatever, and you have 30 different values in the column, oftentimes machine learning workflows, you used to have to one-hot encode those columns. So for however many animals you have in that column, you have 30 more columns or whatever. And of course, if you train your model on more columns of data, then your model training will be slow. It also causes other problems too that relate to accuracy. So I'm not going to talk about how specifically this works because it's not an ML talk, but I just want to let you know that these slides will be available after and we can talk about it later if you're curious. So one really important thing for machine learning is changing your solver. A lot of machine learning in general is based on minimizing some sort of loss function. And there's a lot of different ways to do that. And there's a lot of different algorithms that can help you accomplish your goals. So optimization functions in Python, machine learning, at least for scikit-learn, are called solvers. And the idea here is really simple, is that better algorithms allow you to get down the hill faster. If you want to minimize some sort of function, different algorithms are faster. So one thing to mention here is that when you're finding a loss and you're adding it all up and trying to minimize it, if you do the loss for the entire data set, my screen sharing was paused, it says. Anyone still see my screen? Or did I lose
I can still see your screen, but it's
cool.
still on the original slide.
Oh, I'm so sorry. Okay. Why was it paused? Did I lose access to share? Let me stop and reshare. If I'll just run through this way. Share screen. I'll just share my desktop and we'll do it quickly. Okay. So essentially there's multiple different ways and I'm just going through them very quickly. So of course, one way is to change your solver. And essentially the idea here is when you're going through your entire data to try to minimize some sort of function, if you add up a lot of more numbers, it takes longer to do something. However, if you sample, you basically take, if you have n rows of data and you do, n divided by 5, well, this will happen a lot faster if you sample properly. There's also algorithmic improvements along with sampling that can make it so you get to the bottom of the hill faster. So there's a lot of different ways to do this, but in practice in scikit-learn, it really is a one-line change, really quick one-liner that can save you a lot of time. So if you understand how solvers work, you can basically save you a lot of training time, and then you can often lead to better performance as well, which is kind of another benefit as well. So I should mention here, though, that some solvers are good for different situations, right? Not every algorithm is good for every occasion. So check out the documentation if you're curious about what solver to use for different use cases. So another thing to mention here, and another different sort of technique, is in machine learning, you often have a lot of different candidate models, and you choose between the best candidate model to use in production, basically. And the way you do this is through hyperparameter tuning, oftentimes. And essentially, with hyperparameter tuning, you can think of it as having a long list of different possible values for a given hyperparameter. And there's a lot of different ways to iterate through this list. You can go through every possible combination of hyperparameters. And obviously, that's a pretty exhaustive search. This is called a grid search in machine learning. However, you can also do some sort of sampling approach, like a random search, where essentially you just sample from your giant list or list of lists, and you're able to get to the best model quicker. So if you go through every possible combination for hyperparameters in machine learning, this can often take a long, long time. It can be very painful because if you have 3 different hyperparameters you want to optimize for, and each one of them has 3 different values, 3 times 3 times 3 is 27 different evaluations. And in machine learning, this often can get way out of control. And in scikit-learn, of course, hyperparameter tuning can take a little bit of time, but luckily there's a lot of inbuilt functions and methods that can allow you to do grid search. Or if you want to do something that's more efficient, you can do a random search. So in this image here, I have 81 configurations for a given piece of code. Not important what I'm doing here. But essentially just by changing one thing, by sampling, I can go down in performance time from a couple of minutes to about 25 seconds. And so from 81 evaluations, I went down to about 10. So that can make a big difference. This is just by sampling. And of course, there's other techniques that I really encourage you to read about if you actually care about this topic. But these little things can add up and lead to a lot better performance, because oftentimes it's not just, oh, if I want the best performance, I try every combination. Well, in real life, you often have computing resource limitations. You have time limitations to retrain a model. So using sort of techniques can lead to better performance, oftentimes because you're doing something more efficiently and you're constrained within a given budget as well. So there's a lot of different libraries that have other different hyperparameter tuning techniques included. So scikit-learn typically has grid search and random search, but there's also Bayesian search, early stopping, as well as other things. There's a library called tune-scikit-learn that allows you to do this. One thing to mention here is that if you're not really from an ML background, you just want to brute force it, there's a lot of different ways to do it. So in scikit-learn, typically you're working off one core. And if you have a laptop that has 4 cores or 8 cores, and your code's only using a single core, you're wasting a lot of things that could be parallelized or even distributed in some cases. So my computer by default has about 4 cores that I'm doing a presentation on. And basically, if I was to do things more efficiently with scikit-learn, I could have a performance improvement up to 4x if I use my cores very efficiently. This is really important, as oftentimes a lot of models are very parallelizable. What this means is you can train different models or different parts of your model in parallel and basically have a voting system as well. This is just for a particular model called a random forest, but there's so many different models that you can train your model in parallel or go through your data in parallel, et cetera, et cetera. So there's a lot of different ways to do this in scikit-learn. Really, it's just changing a single parameter as well called end_jobs. You can do this through the Loki backend within scikit-learn. This basically allows you to take from a single core to multi-core, but there's other things you can do as well, like parallelize or even distribute your computation. And if you see this image here, one thing to note here is that distributed computing doesn't always work like you'd expect, because you see all the dogs lined up to eat food, but in reality, distributed computing can be very, very messy. So that's where frameworks like Dask and Ray come in. And basically, they make it so you don't have to deal with all the complicated stuff with distributed computing. Of course, different backends work better for different use cases, because sometimes models are more optimized for one backend or another. So really look at the documentation, do some research, and more. So that really concludes my quick talk. And if you're curious and want to know more, please let me know. The longer form of this presentation is available on SlideShare. And feel free to message me about anything. Thanks. And that was very quick, hopefully.
Thank you. Do we have a minute for questions, or should we save those for the end, Michael?
Whenever. I'm happy to answer whenever if you have questions. And sorry if people can only see the first slide for a while there.
Any questions before we move on?
Questions, comments, concerns? Okay.
I'm interested in the making more use of your cores, like with virtual machines. You know how it's like, hey, you only need one. You're like, no, give me two. What was your learning curve like for you to find modules or chunks of Python code to make use of parallelization?
So I think the thing is parallelization is easier to do for scikit-learn. Distributing using multiple different nodes, that's the problem. That's the learning curve. With parallelization, it really is changing one parameter, even if you have virtual, cores or whatever. But distributing across multiple nodes, that can be very painful. And that learning curve is really just getting familiar with distributed computing, which is harder said than done. Yeah.
Cool. Any other questions?
Yeah. You mentioned, let's see, Dask and Ray. Do you know the difference between those two?
Okay, so in order to make this very, very quick, so I'd say Dask is a bit more middle to high level than Ray. So Dask, I would argue, I used to work for the company that came up with Ray, like the industrial version, Anyscale. But essentially, Dask is a bit higher level. You sacrifice optimal performance by using Dask, but it's easier to use in general. But Ray is a bit lower level, so it's more optimized in distributed computing fashion. It uses the actor model versus Dask doesn't. I could send a whole different comparison sheet. It's pretty long.